All right, so here we go. You've already seen the introduction video. You know the deal. I'm here to get you through the material, make you understand it, and go from there. So good news is you're here. Bad news is you're here. So here we go. Let's go through some of this stuff, get it going. We already talked briefly about this. You've already seen one class with me. So I have to make you think, make certain you understand the material, and answer any questions you had to bridge the gap between those two. You have to think through the material. You have to logically, sequentially think on the process, how the problems are solved, and what you don't understand. So if you ever get caught up, find me, ask some questions, we'll go from there. Chapter 1's real quick. What's physics? Measurements, language of physics that you'll see over and over again. Objectives. That's awesome. The picture's going. So, goal of physics. Basically, it's all the stuff that you see on the physical world and just can't put a picture to. If it's a motion, it's an equation, it's in some cases a force. Why does something do the way it does? In most cases, it's a physics answer. In most cases, some are biology. We'll leave that for someone else to teach. So the nice news is you should be able to make predictions about what other things happened. And sometimes, in some cases, some of the physics stuff you'll find really will lead you into new discoveries about different things. So hopefully you get there, but if not, we'll go from there. Branches. So easy enough. These are the branches of physics. Mechanics is all the motion. Thermodynamics, I would love to get to. We'll see if we get there. Vibrations and waves. Optics, electromagnetism, relativity, and quantum mechanics. Those last three we typically don't get to in a year just because we run out of time. Almost the entire first semester will be spent on that first one with mechanics. How does an object move? Why does it move? What's friction, weight, all the different objects and how they move? That's going to be our focus for almost the entire first semester. So hold on to your hat. Here we go. So physics and technology, lovely car from like 20 years ago. There you go. Scientific method, you guys have seen this before. I'm not wasting your time. If you need to, take a second, look through the slide. So models, we will actually do a few labs in here over the course of the year. A lot of them will be through PhET, P-H-E-T. They do a lot of simulations that are kind of cool. Allow you to play with some stuff that we can't do in class, you know, like dropping a bowling ball off a cliff, dropping file cabinets off a cliff, sliding things. They're pretty cool. Whole thing's a system. You guys understand that from chemistry. 7 base units. There you go. This should be a review of chemistry. Take a second, look at the slide. If you have questions, let me know, and we can talk about this in class. Prefixes. You have got to understand prefixes. If you don't by now, write them down 1,000 times until you figure it out. Several: nano, micro, milli, centi, all of those. On the big side, you have mega and kilo. So mega and kilo are your two big ones. Every once in a while, we'll see a giga, but very rarely. So again, nano, micro, milli, centi, kilo, mega. You got to know those. Dimensions, all the things have dimensions. Very rarely will you have anything without a label. It has happened, it will happen again, but it's very rare. Example, friction. So here's a sample problem. You're given a mass of 2.0 Fg. If you think back to the chart we just looked at, what's the mass in grams? What's the mass in kilograms? And again, this is where conversions happen. Fg is not a big one, but set it up. Dimensional analysis will be used over and over and over again. So again, you know the two equations. Set it up just like dimensional analysis, get your answer. Now, if you notice something, the answer is just not 2. The answer is 2.0. Significant digits are coming back. So, accuracy and precision, just like chemistry, accuracy is how close you are to the correct value. Accuracy to the correct value. Precision is the degree in which you're going to hit the same measurement over and over and over again. Precision over and over and over again. So let's get right to it. Don't know where my pictures are going. And so yes, significant digits. Yes, they have to be used. In most cases, You only round at the very end. And for a lot of you, that's going to be where the complication lies, because you don't round once in the middle, once towards the end, and then again at the end. You have to think through, okay, I had 2 significant digits, 3 significant digits here. How many should I have in my answer? So yes, the rules, numbers are significant, zeros between numbers are significant, zeros to the right of a decimal and to the right of numbers. Last one we're adding, unusual numbers. There is some circumstances. The easy ones, 60 minutes in an hour. 1 hour, that's a count, so it is an infinite number of significant digits. The 60 minutes, count, infinite. There is some unusual numbers we'll get to, especially when we start talking about sine, cosine, tangent, and angles. So we'll talk about how you round. Again, make certain you read through. 1 significant digit outside is your uncertainty. For measurements, take a second, look at the ruler. You know there's 18 point, I would say 0.5. That uncertainty, that 0.5 is your uncertain one, so you have 3 significant digits. There's a long version and some examples. If you need to, take some time, write them down. If you need to review them, we'll spend a little bit of time on them in class, but not a lot. We've got 2 days on this chapter. So here we go. So addition and subtraction, there's the rules. Again, not a lot of time to rehash stuff you should have learned in chemistry, but we can. Rounding down, rounding up. This should not be anything amazing. That was section 1 and 2. The language of physics, this is where you need to kind of start thinking about magnitude and the numbers versus the labels. So, example, most of the time you will have information. Hopefully, you'll have information that comes out in a table format. You organize your information like this. You should be able to make a chart. Again, not earth-shattering, but we'll have to do it and have to be able to understand what the charts give us. Equations, all right. This should be the way it works. Variables will be boldface or italicized. Units. Sometimes Roman letters, very rarely, sometimes Greek letters. Dimensional analysis, ordinate magnitudes, everything you did in chemistry will come back. Example, there's your equation. Greek letter delta, change in. You'll use that one quite often. Change in t, change in y. It's awesome. None of my equations, my pictures are showing yet. So that wraps up, really, chapter 1. Very quick. We'll answer more questions in class. We'll probably do a little bit of work, but chapter 1, done.